Hi, in this lesson, I will give you some tips for becoming better at proving trigonometric identities. First, I'll talk about the difference between identities and equations. Then, we will talk about some useful background math skills that you might need. And finally, I will work out some examples. What are equations? This is an example of an equation. And the thing about equations is that they do not always hold. With an equation, what we do is we try to solve the equation. That is, in this case, to find the values of x that make the equation true. And so in this case, all of us know that if x equals to half, then 2x is equals to 1. Here's another example of an equation, x squared minus 1 equals to 0. X squared minus 1 is not always equals to 0, but if x is equals to 1 or minus 1, then x squared minus 1 equals to 0. And so if we want to solve this equation, we find the values of x to make the equation true. What are identities? This is an example of an identity. If you know your algebra, you know that the left-hand side, x plus 1 bracket square, is actually equals to the right-hand side, x squared plus 2x plus 1, regardless of the value of x. So an identity is just a relation that is always true. And so when we are given an identity, what we are trying to do is we want to prove the identity. In other words, we want to show that the left-hand side is equals to the right-hand side, regardless of the value of x. Here I have another exact example. X cubed minus y cubed on the left-hand side is equals to, on the right-hand side, x minus y times x squared plus xy plus y squared. And if you know your algebra, you know that the left-hand side is always equals to the right-hand side, regardless of the value of x and the value of y. So this is an identity. Next, let's talk about some useful math skills. 1. You should be good at simplifying fractions, multiplying, dividing, adding, subtracting. Then, you need to be familiar with some simple factorization formulas. And finally, you need to have some basic trigonometric knowledge. This is not a lesson on fractions, so I won't go into great detail, but I'll only highlight some operations that you should aim to be good at. So here I have, on the left-hand side, a divided by the fraction b over c, and it should be clear to you that that is equals to ac over b. Similarly, if I have a over b, the fraction a over b, divided by c, that simplifies to a over bc. If I have two fractions and I want to add them together, I have to take a common denominator, bd, and then change the numerator to become ad plus bc. And if I subtract two fractions, it's almost the same, except that there's a negative sign instead. And here I have two other examples that you can try and simplify. And so it is important that you not make mistakes when you simplify trigonometric fractions, because otherwise you won't be able to prove the identities. Sometimes, to prove trigonometric identities, you will need to be able to do some factorization. So here are some factorization formulas. X plus y bracket square is equals to x squared plus 2x plus 2xy plus y squared. That's one of the formulas that you should be familiar with. Similarly, x minus y squared is equals to x squared minus 2xy plus y squared. That's another formula. The next one is very useful. X squared minus y squared can be factorized to become x plus y, x minus y. And this one is actually an application of the previous formula. X to the power 4 minus y to the power 4 can be factorized to be x squared plus y squared times x squared minus y squared. And furthermore, x squared minus y squared can be factorized again to give you that. And then here are two more formulas that may be useful. And we will of course need some basic trigonometric knowledge to be able to prove the identities. The simplest one is that tangent x is equals to sine x over cos x. So sometimes you will need to change tangent x to become sine over cos. Sometimes you need to go the other way. And then you need to know all the reciprocals of the basic trigonometric functions. Cotangent x is equals to 1 over tangent x. Secant x equals to 1 over cos x. And cosecant x equals to 1 over sine x. And the way I remember it is that each pair has only one co. So with tangent, you have cotangent. With cosine, you have secant. And with sine, you have cosecant. A very common identity that can be used is that sine square x plus cos square x equals to 1. And that can be proved using the Pythagoras theorem. You have to be very familiar with this identity, as well as its variations. So for example, sine square x can be replaced with 1 minus cos square x. Cos square x can be replaced with 1 minus sine square x. And if you are familiar with factorization, 1 minus sine square x can actually be factorized to become 1 plus sine x, 1 minus sine x. Other variations include tangent square x plus 1 equals to secant square x, and that is taking the sine square plus cos square equals to 1 and dividing every term by cos square x. That will give you tangent square plus 1 equals to secant square. And if you take sine square x plus cos square x equals to 1 and divide by sine square x, you get the next identity, which is 1 plus cotangent square x equals to cosecant square x. And so these are some basic formulas for trigonometry that will be useful. Let's try to work out some examples. So here we are trying to prove that tangent x times sine x plus cos x equals to secant x. And so a useful strategy is to start from the more complicated side and then at each step try to simplify the expression. So in this case, the more complicated side is the left-hand side. So we start with tangent x times sine x plus cos x. And we see that there is a sine x and a cos x, and we remember that tangent x is equals to sine x over cos x, so let's do that. And so now we have sine x over cos x times sine x plus cos x. And the first term we can simplify a little bit by combining the sine x's together. And this gives us sine square x over cos x plus cos x. And this is a fraction. And so we want to simplify the fractions, we combine them together. And so we take common denominator, and the numerator becomes sine square x plus cos square x, which we remember is equals to 1. And so we can replace the numerator with 1, and so we have 1 over cos x. And then lastly, we remember that 1 over cos x is actually secant x. And so now we have the left-hand side, tangent x times sine x plus cos x equals to the right-hand side, secant x. Now let's try to look at a more complicated looking example. Again, we want to start from the more complicated side, so we start from the right-hand side in this case. And it is really complicated looking, but it's just two fractions. And so the aim is to try to simplify them as much as we can. And so to simplify fractions, we take a common denominator. So we take the common denominator. And when we take the common denominator, we have to adjust the numerator as well. And so this is what the numerator looks like. And then we want to simplify this as much as we can. And we're going to keep the denominator as it is. And to simplify the numerator, well, the next thing to do is to try and expand 1 plus sine bracket square. So let's expand it. And when we expand it, we get in the numerator cos square x plus sine square x plus 2 sine x plus 1. And then once you see cos square x plus sine square x, we should be very happy that becomes 1. And so the 1 combines with the other 1 at the end to give you 2 plus 2 sine x in the numerator and 1 plus sine x times cos x in the denominator. And we want to simplify this even more. There's a common factor of 2, so let's take it out. And once you do that, you can see that the 1 plus sine x can be cancelled, and this gives you 2 secant x, which is the left-hand side. Let's do one last example. So again, in this case, the right-hand side looks more complicated, so we're going to start with the right-hand side. And we see that there's a bunch of tangent, cotangent, cosecant, and so on, and this is quite complicated. But we can convert it all to sine and cos. So that's also something that is useful. Sometimes if there are a lot of tangents and cotangents and secants and cosecants, just change them all to sine and cosine, because that's usually what we are more familiar with. And so the cosecant x is actually 1 over sine x, the tangent x is sine x over cos x, and cotangent x is equals to cos x over sine x. And so here you have a bunch of fractions, and so the goal is to simplify them as much as possible. And the first thing to do is to take the denominator, which is actually the sum of two fractions, and combine them using common denominator, and this is what we get. And notice that this is equals to 1, so we can replace it with 1. And now we have a fraction, cos x over sine x, divide by another fraction, 1 over sine x cos x. And so here you have to be careful about simplifying fractions. The numerator becomes cos x over sine x, and for the denominator you have to flip it over to get this, and the sine x cancels, and what you have is cos square x, which is equals to the left hand side. So here's a summary. First, you have to review your algebra and make sure you are comfortable with simplifying fractions, performing factorization, and simplifying algebraic expressions. You have to be able to do all these without making mistakes, so that you can go from one step to the next step and know that it's correct. And then you need to be familiar with simple trigonometric identities. Sine squared plus cos squared equals to 1. Tangent x equals to sine x over cos x. Cosecant x is 1 over sine x. Secant x equals to 1 over cos x. And know how to use them. And then a strategy that is always useful is to start with the more complicated side and then use algebra skills to simplify to get to the simpler side. A picture that can show this is, let's say the left-hand side is the more complicated side. You start with the left-hand side and you follow a bunch of steps, and the aim is to make it look more and more like the right-hand side by simplifying. Now, sometimes it's not possible to do this, in which case what you can do is to start from the more complicated side, let's say it's the left-hand side, and go and simplify as much as you can. And if you can't go any further, stop there and then start from the right-hand side and try to get from the right-hand side to the same expression. So this is like coming from both ends. And lastly, try to work with sine and cos rather than cotangent, cosecant, and secant. Unless you're really good at cotangent, cosecant, and secant, it's often easier to just switch all these expressions to sine and cos. So I hope this has been useful. All the best.